Okay, let's just jump right in. Welcome to today's Explainer, where we're going to explore the absolutely fascinating and, honestly, sometimes a little intimidating world of open source intelligence. You'll usually hear this called OSINT for short. If you've ever wondered how security analysts, journalists, or even malicious threat actors manage to piece together incredibly detailed profiles from seemingly random bits of public data, well, you are in exactly the right place. Today, we're going to uncover exactly how vast amounts of publicly available information are systematically transformed into real, actionable intelligence. To really build this from the ground up, let's start with a foundational definition from Mark M. Lowenthal over at Columbia University. He defines OSINT as any and all information that can be obtained from overt collection. The absolutely vital word to focus on there is overt. OSINT is a structured intelligence gathering technique that relies entirely on public channels. It is not hacking, it's not stealing, it is simply the systematic analytical collection of what is already out there, everything from boring government reports to the deepest corners of the internet. Here is our game plan for today. We'll start by properly defining what OSINT is. Then, we'll look at the crucial difference between raw data and actual information. Third, we'll open up the reconnaissance toolbox. Fourth, we'll talk about extracting the invisible. And finally, we'll wrap up with the most important step, verification and cross-referencing. Think of our journey today sort of like an iceberg. What we easily see on the surface web, your standard Google searches, public social media profiles, basic news sites, that's literally just the tip. It's a tiny, tiny fraction of the publicly available data waiting to be discovered. As we descend into the deep web and peer-to-peer networks, we start finding databases, archives, and connected devices that are 100% public, but practically invisible to a casual web browser. So, part one, what exactly is OSINT? Now, here's a really crucial distinction we need to make right out of the gate. You have to understand the difference between OSINT and SIGINT, which stands for Signals Intelligence. OSINT relies entirely on legal, publicly accessible data. You don't need a top-secret clearance or a judge's warrant to collect it, because it doesn't breach any copyright or privacy laws. Signaled, on the flip side, deals with intercepting classified electronic signals and communications. That requires strict legal frameworks and serious government authority. The big takeaway here? OSINT is something that anyone with a computer and an internet connection can technically do. Moving right along to part two, data versus information. There is a very specific flow to the intelligence pipeline. It always begins with raw, unedited open source data, or OSD. Think of this as your primary source material, things like raw satellite imagery, unprocessed telephone metadata, or just a massive list of IP addresses. On its own, it's not super helpful. So to make it useful, analysts filter and process this OSD to create open source information, or OSINT. These are your secondary sources, a structured news article, an academic dissertation, or a specific report. OSINT, the actual actionable intelligence, is what you get when you finally analyze all of this processed information together to answer a specific question. Now, a massive piece of this information ecosystem exists just below the surface, in what the intelligence community calls gray literature. This is information that is legally available to the public, sure, but it doesn't just pop up on page one of a Google search. It's usually controlled by whoever produced it. That means you might need to know the exact database to search, or you might even have to pay a subscription fee or request special permission to access it. So, what exactly are we talking about here? Well, it includes an incredible depth of structured data. We're talking academic dissertations, dense corporate filings, technical patents, and commercial imagery. For a serious investigator, this stuff is absolute gold. Think about it. If you're researching a company, their slick marketing website is just the surface web. But their technical patents, obscure business registries, and unpublished working papers, that's gray literature, and it tells a much more accurate, unvarnished story of what that company is actually up to. All right, section 3, the reconnaissance toolbox. Just look at the sheer scale of the OSINT framework tree. It's pretty wild. This widely used resource categorizes 32 different types of target objects. It maps out everything from how to track down isolated email addresses and domain names, all the way to navigating the dark web, following digital currency trails, and doing malicious file analysis. What this really shows us is that OSINT is definitely not just Googling a name. It's a highly categorized, incredibly systematic approach to following digital breadcrumbs. Let's break down some of these specific tools by their actual function. By mechanizing their workflow, investigators can uncover some truly incredible things. For example, using the Wayback Machine or archive.is, you can pull up historical copies of websites, completely recovering pages a target thought they had permanently deleted. Then you have tools like Shodan and Zoomy. These act as search engines, but not for websites. They search for connected devices, revealing exposed IP addresses and open network ports. For leaked data, a tool like Have I Been Pwned can tell you instantly if an email was caught in a data breach. And for accessing that gray literature we mentioned, databases like Factiva or Core tap right into millions of global news sources and academic papers.
Which brings us to part 4, extracting the invisible.
So the crucial thing to realize here is that professionals aren't just sitting at their desks manually clicking through websites and copy-pasting text. They write automated scripts and use APIs, that stands for Application Programming Interfaces, to systematically scrape massive data sets. They target both structured data, which is that neatly organized information like tables and lists, and unstructured data, which is the messy stuff, raw text, social media feeds, and media files. By automating the process, a single researcher can pull thousands of records in the exact same time it takes a normal person to read one single web page. And unfortunately, threat actors know this too. This automated extraction is exactly what happens in the very first stage of a cyber attack. If we look at the MITRE ATT-NTF framework, which is a global knowledge base of adversary tactics, the very first phase is reconnaissance. Malicious actors use these exact same OSINT tools, APIs, and automated extraction methods to map out an organization's weak points. They're finding employee emails, identifying trusted networks, and discovering unpatched software, all from public, perfectly legal open sources, long before they ever launch a hack. Finally, Section 5, verification and cross-referencing. Because this data is incredibly powerful and, let's be honest, easily manipulated, just finding it is only the beginning. You can't ever trust a single source without rigorous corroboration. To build reliable, truly actionable intelligence, investigators stick to a strict 3-step methodology. Step 1 is source verification. You absolutely have to check the credibility and background of the platform or the author. Step 2 is cross-referencing. You must compare that data against diverse primary and secondary sources. And Step 3 is fact-checking, utilizing specialized organizations to actively debunk false claims. Let's drill down into some best practices for that cross-referencing phase, because this is what ultimately separates a wild internet rumor from actual intelligence. You must gather data from diverse, completely independent sources. Say you find a target's address on some random people search website. Well, that's pretty low confidence. But if you cross-reference that and find the exact same address in an official county tax parcel database, a primary government record, your confidence level just skyrocketed. You always have to look for consistency, actively resolve any conflicting data, and watch how that information shifts and changes over time. I want to leave you with this final, somewhat provocative thought for today's explainer. Having just seen the true depth of the information iceberg, understanding the jump from raw data to gray literature, and knowing the automated power of the tools used to mine it all, what exactly does your own digital footprint look like from the outside? If an intelligence analyst turned the OSINT framework on your public presence right this second, what kind of profile could they build? It's a fascinating and maybe a little sobering question to chew on. Thanks so much for learning with us today, and we'll see you in the next explainer.